Hello everyone, welcome to ChemUp Academy, where chemistry is simplified and success is amplified. So, in today's lecture, we shall be starting with our new topic, namely okay. So, topic for today, this is gonna be your first class again for prelims, and we are starting another topic for our physical chemistry. And the name of the topic, you can write the name of the unit as solutions and colligative properties. So major portion is based on the colligative properties, which we all know that there are 4 colligative properties. We shall be discussing about them in detail. This is your lecture number 1, and it is your duty to keep a track on the number of lectures that are going on. And the topic that we shall be discussing for today shall be your solutions. In solutions, when we say we have 2 topics to cover, that means first is our Henry's law and another one is our Raoult's law. So I'll try to complete both of them today, but if the video exceeds, then I will pause at Henry's law and then I will continue with the Raoult's law in the next video. So major topic I have taken it over here. So let's come on to our topic, that means solutions. When we talk of solutions, we have a basic definition in our mind that wherever there is a homogeneous mixture of either liquid with solid, liquid with gas, solid with solid, or anything, like anything that could be. So we call it what? We call it a solution. That solution represents the unique properties as compared to its components or its constituents. So if I write a definition wise, what I can say is that when I say definition wise, I can say a homogeneous, or it could be sometimes hetero as well. ठीक है? A homogeneous mixture of two or more components which have a unique property. Depending on the amount of components we are using, our solution could be binary, ternary, or quaternary, and so on. The solutions could vary like that. But the major thing that we need to focus upon is that if we are talking in terms of solutions, the solution has two major portions. One is that it is having a solute, and another thing is that it is having a solvent. We cannot say that always solute will be always solid and solvent will always be liquid. नहीं, जो कम amount में होगा that will be your solute, less amount, and the thing that is present in major portion will be your solvent, more amount. Like that we describe कि solute क्या होगा और solvent क्या होगा. Like if I am taking a mixture of very known particular thing, that means glucose in water. Here glucose will be my solute and water will be my solvent. So something which is in less quantity as compared to the other quantity, that gives me my I would say solute and solvent regarding the solutions. So this was just the brief discussion about what we shall be proceeding in today's lecture. Also, we have certain sort of volatile components, non-volatile components. So that could be the major portion that we would be dealing in the Raoult's law. Now, if we talk about the type of solutions that we can have, say we have the liquid solutions, we have the liquid as our solvent. This is our topic to focus upon. बहुत सारे हो सकते हैं, but what we are focusing upon is here we have solvent as liquid. But what if I take my solute as gas, what if I take my solute as solid? It can be both volatile or it can be non-volatile. So, whenever I talk in such terms, that means solute is my volatile solid and liquid is my solvent, then I shall be considering a Raoult's law. When I say that the component that I shall be using with this particular solvent is non-volatile solid, then I would say that those are my colligative properties. And when we talk about when we talk about this particular solute that is gaseous in nature, then what I can say is that this will always talk about my Henry's law. Hence, we can consider that the liquid that we are having, that means the liquid that we are having, oh sorry, this is liquid, and here we have solid. Again, they could be of two types, volatile and non-volatile. Here also they could be volatile or non-volatile. I just did a mistake. It was in my mind, but okay. So when we are taking liquid as a solvent and solute as a gas, we'll always consider our Henry's law. For our Raoult's law, we have volatile, non-volatile, that could be liquid. And for solid state, we have our colligative properties along with the solvent that is present in the liquid. So this is how we shall be discussing about the points. So coming on to this particular case of ours, let's consider this case, that means the Henry's law. What does Henry's law say? It says that there's a solution like this. It says that there's a tumbler like this in which my liquid is present. This is my liquid. And above this liquid, I have certain drops, or I would say this must not be visible. So above this liquid, I have a gas. This is my solution in which my liquid is there and my gas is there, and this is the gas present alone. Gas present alone. What if I apply a piston over here? This is my piston. Now since we are considering Henry's law, तो थोड़ा ध्यान से सुनना एक बार. Henry's law says that there's a piston, there's a gas, and there is this liquid of ours. This is our liquid, whole liquid it is. When we consider this liquid, when we consider this liquid, we can say that the amount of gas which is dissolved in this solution or in this solvent above its partial pressure is directly proportional to its mole fraction. Matlab, the partial pressure of the gas, that means partial pressure of the gas, say we have gas, any gas, is directly proportional to its solubility in that particular thing represented by its mole fraction. Solubility represented by its mole fraction. मतलब जितने भी number of moles, mole fraction, जितने भी number of moles of fraction dissolvable होंगे gas के अंदर, that will be directly proportional to the partial pressure of the gas. So in order to remove this proportionality sign, what we can say is, we can say that partial pressure of gas is equal to Kh into mole fraction of that gas. This is how we can represent. Partial pressure it is Henry's constant, and it is obviously the moles. So I hope you all know how to calculate the moles, and this is all about the Henry's law. But Henry's law के साथ साथ there is one more thing that we should consider, and that is this particular thing. That means Henry's constant, जो कि पर्टिकुलर चीजों के ऊपर डिपेंड करता है. कौन सी चीजें हो सकती हैं जिनके ऊपर ये डिपेंड करता है? हेनरीज कांस्टेंट डिपेंड करता है आपका पहला टेम्परेचर के ऊपर, दूसरा नेचर ऑफ सल्यूट, और तीसरा नेचर ऑफ गैस. यहाँ पे सॉल्वेंट लिख लेते हैं बिकॉज वी आर टॉकिंग सल्यूट एज गैस ओनली, तो लेट मी जस्ट राइट इट एज सॉल्वेंट. तो ये बेसिक तीन चीजें होती हैं जिनके ऊपर हमारा हेनरीज कांस्टेंट डिपेंड करता है. इसी से रिलेटेड एक क्वेश्चन वाज आस्क्ड in your PYQ for UPSC. So I'll just bring it in front of you. I guess so this, yeah. The question says that consider the Henry's. The question says that consider the Henry's law for the following. Henry's law constant depends on the nature of gas, which we know is true. Another thing, carbon dioxide more soluble than oxygen. Let's consider it. KH does not depend on nature of solvent. Of course, it's false because KH is the Henry's constant and it do depend on the nature of the solvent. Then we have KH depends on temperature. Of course, it depends on temperature. Therefore, this question I guess was your part of 2024 question paper and it was asked. So I would like all of you to take its screenshot so that it stays with you. And for this consideration, they had given the KH value for CO2 as well and KH value for O2 as well. So one thing that you can remember about this particular thing is that more the KH, more the value of KH, less will be the solubility. So if you will compare these two values of KH, you can get to the answer directly. Now, let's solve certain numericals related to this particular thing. Okay, we can solve this thing. The question says in itself that Henry's constant for nitrogen dissolved in water is 10 to the power 5 atm. That means we have the value for KH as 10 to the power 5 atm. Now, mole fraction of nitrogen is itna, then find the number of moles in the nitrogen. Let's apply. Okay, here we have this particular thing, so we can place Pn2 will give me KH with mole fraction of N2. And according to this particular thing, I know how can I write the mole fraction. Mole fraction could be written as N2, number of moles, N2, and that of water because it is dissolved in water. And with respect to water, I can just neglect it. So I can write it as N2 upon NH2O. So this could be further simplified as KH into N2 upon NH2O. Like this I can write, simple. Then they say the nitrogen dissolved in 10 moles of water. So the 10 moles of water could be placed over here. 5 atm pressure. So for this particular question, we need to first solve using Dalton's principle. According to the Dalton's principle, what we have is, or what we can use is, Dalton principle says that partial pressure of any gas is equal to total pressure into its mole fraction. This is how we can directly calculate. So let's just calculate how many, what shall be the P total that we can have. So it is saying that Pn2 we need to calculate, and and they are giving us 5 atmospheric pressure. That means the total pressure is given to us over here, and then we can multiply it by 0.8 over here, this value. So we will get 4 atm. So now we can place this value over here. 4 atm is equals to kh, they have given 10 to the power 5 atm into n. N2 we need to calculate, upon water we have it as itna, then we can cut it down to the power 4, and therefore n N2 of R becomes 4 10 to the power minus 4 moles, and hence the question could be solved easily by just knowing a single formula, that means this. So this was all about our Raoult's law. Raoult's law says that, oh sorry, Henry's law. Henry's law says that whenever there is a solution, whenever there is a solution of gas, the solubility of gas, that means I can say that solubility of gas is directly proportional to what? To the pressure of gas. This was the original, but later on it was modified, and hence another term was added to it, that means the partial pressure. Partial pressure. So this is the modified version of Henry's law. Modified version of Henry's law. मतलब आपके पास कोई सोल्यूशन है, उसके अंदर आपकी गैस कितनी ज्यादा डिसॉल्व हुई है वो डिपेंड करता है उसके मोल्स के ऊपर. मोल सॉल्युबिलिटी को ही डिटरमाइन करते हैं और उसके पार्शियल प्रेशर के ऊपर वो डिपेंड करता है. मतलब जितना ज्यादा पार्शियल प्रेशर होगा उतनी ज्यादा आपकी सॉल्युबिलिटी होगी, पर जितना ज्यादा आपका केएच होगा उतनी कम आपकी सॉल्युबिलिटी होगी. मतलब कि if I tend to increase my pressure, the solubility increases. But if I increase the temperature, solubility for gas decreases. This thing you should keep in mind, that whenever I will increase my pressure, the solubility of gas will increase. But what if I increase my temperature? Therefore, the solubility of my gas will decrease. But for solids, according to the temperature, that means as the temperature increases, solubility भी आपकी increase करेगी for solid, but decrease करेगी for gases. This is the main point to remember. So you can mark it as important. Now coming on to its applications. Applications of Raoult's law. Applications के बारे में आपने बहुत जगह पर देखा होगा. We have carbonated drinks. We have carbonated drinks. Carbonated drinks usually high pressure को follow करती है. Since बहुत ज़्यादा high pressure रहता है तो गैस लिक्विड के अंदर dissolve हो जाती है. That will give you a frizzy taste whenever you will taste it. So एक तो ये हो गया. दूसरा we have scuba divers. We have scuba divers. ठीक है, आपने मनाली में देखा होगा, बाली में देखा होगा, people go and just do the scuba diving. So that particular thing, those people actually carry what? They carry the oxygen cylinder, and once they carry that oxygen cylinder, तो उसके अंदर pressure इतना high होता है ऑक्सीजन का कि that cylinder contains oxygen in its liquid form. Because of high pressure, जो गैस होनी चाहिए थी at normal temperature, it is converted into the liquid. So एक ये बात ध्यान रखनी है. Next thing is that its limitations. अब limitations क्या हो सकती हैं? Limitation सिर्फ एक है इसके लिए, क्या? It will only be applicable to the diluted solutions. इसकी सिर्फ एक लिमिटेशन है कि ये सिर्फ उन्हीं चीजों के ऊपर एप्लीकेबल है जहां पर डाइल्यूटेड सॉल्यूशंस है और जहां पर वी आर नॉट कंसिडरिंग एक्सट्रीम प्रेशर कंडीशंस. एक्सट्रीम प्रेशर कंडीशंस, सिर्फ ये ही इसकी लिमिटेशन है हेनरीज लॉ की. तो दे कैन आस्क यू लाइक what are the drawbacks of Henry's law? Not direct question, but a theory based question like this could be asked in your examination, like Okay, we have one more question for you. So we can solve this question. This says that we have the KH value. KH value for oxygen is given to us when its partial pressure is this much. So let's just solve it. A simple question it is. We will jot down what all points we have. We have the KH value. This is our KH value. Temperature का कोई काम नहीं होता because temperature always remains constant. Then we have its partial pressure is इतना. So partial pressure की एक value मिल गई. दूसरी particular चीज we have got. Molar concentration they are asking. पहले सबसे पहले लिख लो formula. Partial pressure और P oxygen. Formula लिख लिया. Formula लिखने के बाद चीजें अब place कर देते हैं. That means 8 10 to the power 4 we have into they're asking the molar concentration. Molar concentration तो यही होगी, यही होती है आपकी molar concentration. ठीक है, तो molar concentration इसी को रहने देते हैं like XO2 and we have the partial pressure is 20 kPa. So let's cut down whatever is there. XO2 we have 20 kPa upon 8 10 to the power 4. So it will go by 2 and by 5. So it will become 2.25. XO2 will give me not 2.25, it will give me just 2.5. चलो ऐसे लिख देते हैं. It will give me 2.5. So 2.5 into 10 to the power 4 मोलल में है. ठीक है, kPa इधर था और इधर आपका kPa इधर भी था, kPa इधर भी था, per kg it is. So in per kg it will become molal. That means the digits become this. So let's just check it from this. According to me, the answer is coming out to be this. How come this? Because 0.25 millimoles we have, and here also we have, this could be converted into millimoles. Like what? 2.5 0.25 and 10 to the power 3 goes into millimoles. Therefore, millimoles we can take them. So millimoles per decimeter cube. This is the power like this. It is written like, okay, it's red only. अच्छा, पावर तो इधर लिखी हुई है. ठीक है. So it says that -3. So hence B part becomes our answer. So like this you can easily solve the questions which are related to your Henry's law. Usually such type of questions are asked, and for your information, these were only the PYQs that we have just solved within seconds and within minutes. For the very first time, it was a good attempt. So thank you and keep watching.
ChemUp Academy. Chemistry simplified, success amplified.